All right, folks, probably your last calculus video, I'm hoping, because you guys probably don't want to hear my voice anymore either. Okay, so anyway, we are going to be looking at the volume like we were before, except this time we know what the cross-section is, meaning what shape it's going to be. So a lot of times before we were looking at the cross-section and it was a cylinder, right? So you guys knew the volume of it. So this time, we don't know what shape you're gonna get back. So we're gonna go through each of the functions. Sorry, I'm eating a snack. Okay, so draw a diagram of the base, because basically this is like looking at the base of a function and seeing what the cross section would be. So if you think about like a pyramid, if you took a cross section of that, the shape would actually look like a triangle if you tilted it upwards, okay? So same thing here. So the base is basically like the bottom part of the figure. So if you were to rotate it, the base is that bottom shape. Anyway, if your cross section is perpendicular to the x-axis, you integrate in terms of x. Basically, if it's perpendicular to y, you integrate in terms of y, which is what we've been doing, okay? Same thing as before. Write the function of each cross section, determine the area formula to be used. So for the first one, we're literally just going to set up the integral as we were doing before. So a cool thing that I'm going to show you, which some of you have actually seen before, is how to find the integral on your calculator now. So we don't really have to do a whole lot. However, what I want to know is this area, if these are all the cross sections, okay? So if you can imagine what kind of shape it is, great. If you can't, not a huge deal. We're just going to integrate to find that area. But this whole function would be the base of the figure, okay? The other thing we should notice is that this is actually y equals negative x. A little typo there, okay? It's actually the same function as we had before, except first you have to find the intersection points like we've been doing. This one you just integrate like normal, which is kind of cool. But again, these are going to be perpendicular to these cross sections are going to be perpendicular to your x-axis because they said to. So it means everything's going to be in terms of x, okay? What I want you to do first is figure out those two intersection points. Again, you can set 2 minus x squared equal to negative x and see what the two values are. So pause the video, figure those out, and come back to it. All right, so if you find the intersection between those two, you can move it around, factor. You should get x equals 2 and negative 1. So we're going from negative 1 to 2, which this diagram is a little deceiving because this is supposed to be like negative 1, and that is 2, okay? From there, we need to subtract out. If we're doing our integral vertically, that means that we are going to integrate the top function minus the bottom function. So our top function in this case would be 2 minus x squared. And then we have to subtract out our negative x dx. Okay, no volume formula yet. We'll get to that in a little bit. All right, because we're putting pi in there and squaring the values, but we don't have to worry about that yet. I would just rewrite it a little bit, so it's negative x squared plus x plus 2 dx. Okay, and this is the handy dandy new tool we're going to use, how to integrate, do a definite integral on our calculator. So you need to go to the math button on your calculator. You're going to scroll down to function integral. Hopefully you can find it. If not, I can show you when I see you next. And then you'll see what looks like an integral symbol. So type in your negative 1 in your lower bound, positive 2 on your upper, your function goes in the parentheses, and then we're writing our function in terms of x, so dx. Okay, and then you hit enter and you get your answer of your integral. You don't even have to show me work for the rest of these problems. All right, and then you get 37 over 6 or 6 1/6 for your answer. All right, here comes the fun stuff. So now this deal would be, instead, if you cut that cross section and you knew it was a square. So what you would do is think about the area for a formula of a square, which if you think about it is just going to be your lengths squared or base squared. It's going to be easier if you determine it as base squared because that is the variable that we're using here. It's base. So your base in this case is whatever function you have. So in our scenario, it was the integral from -1 to 2. So now all you're doing is taking that function that is representing your base and squaring it. Okay, because it would be if you took a cross section and you got to square it back. So now just plug that into your calculator as an integral and you get 8.1. All right, so now what if you had a rectangle with a height of 2? So your base is still going to be your function, but now you're just multiplying it by 2 because you already still have your base, you don't know what that is yet. So in this case, it would just be 2 times your integral that you already had, the original integral, not what was above us. And plug that into your calc for now, and you get about 9. Okay, now think about a rectangle with a height that is 3 times the base. So if your rectangle is your length times width, or in this case, base times your height, think about what that would look like. So your base is still going to be the function. For now, we can just do it in terms of b. And then the height is 3 times that base. So it would be 3b squared. So see if you can set up the integral for this part. All right, so hopefully you're setting up your integral as 3, integral -1 to 2 of your, 2 minus x squared plus x squared, because again, it's base squared dx. And then if you put that in your calculator, you end up with 24.3. So you're just estimating what your values would be, what your integrals would be if your bases were these shapes. Equilateral triangle. Okay, so let's draw it out because that'll help us a little bit here. So equilateral triangle means all the sides are going to be equal. If we decide that this whole base is going to be b, that means that this is b and this is b. It also means if I wanted to do 1/2 base times height for my area of a triangle, I need to figure out my height. Now, if you don't remember this, if you have an equilateral triangle, each of these angles is 60 degrees because if you take a 180 and divide it by 3, it is 60, which means this is cut in half, which is 30. So then we have a 30, 60, 90, which means if this is b, that is your hypotenuse. Okay, that means that this is b over 2, and that means that the 60 degrees across from 60 degrees is going to be b over 2 radical 3, so that's your height. So in this case, we have 1/2 b times b over 2 radical 3, and you can clean that up a little bit and make it 1/4 because of the 2's here, b squared radical 3, or you can do radical 3 over 4 b squared, either one. So I can actually pull out that radical 3 over 4 and then integrate my -1 to 2 again. 2 minus x squared plus x squared dx. And you get about 20, nope, that's wrong, 3.5. That would be your area of that shape if it was a triangle. Semicircle, try this one out on your own if you can. Think about what the base would be, basically your whole diameter across. Think about the area of a circle, cut it in half, see if you can get the formula for that. All right, so hopefully you got the formula for it, which is going to be pi r squared over 2. But if you draw our semicircle, this is base. The base is the whole bottom part. So that's your function. So if you solve this out, your radius is actually going to be half of that. So your formula is pi times base over 2 squared divided by 2. So you can just do pi over 2 here. So that really comes out to b squared times pi. Think about the 2 here is going to have to be squared, so that's 4 times 2 over 8. So your integral would be pi over 8, because you can factor that out, times your function squared dx from, again, -1 to 2. And that equals about 3.18. All right. Okay, folks, we only got a few more here. Isosceles right triangle with leg as the cross section. So what that means in all the words that it's saying, got an isosceles right, which means that two of the legs are going to be congruent, which means they both can be our base. It also means that if two of our legs are congruent, these are both 45 degrees. And it also means automatically that the hypotenuse is b radical 2. Although we don't need that because the area of a triangle is 1/2 base times height, and in this case our height is also b. So 1/2 b times b, 1/2 b squared. So when you integrate 1/2 from -1 to 2, this is getting to be the same thing all the time. And it's squared because this is squared. dx. Integrate it in your calculator now for the shortcut, 4.05. All right, isosceles right, a little different. The hypotenuse is the cross section. Okay, so what that means is that's your base. So again, I'm just gonna kind of turn it on its side this time so it's a little easier to look at, and it makes a little more sense because this is now your base. These are still 45, 45, 90. Excuse me. And that also means that you can figure out your height if you cut this right here. That also means that your leg here is going to be b over 2, which means that this is also b over 2 because they're congruent, because it's 45, 45, 90. So your formula for area would be 1/2 base times height again, except our base is b and our height is b over 2. Okay, because it's 1/2 of the whole base. Your whole base is this part. Okay, so you end up with 1/4 b squared. So again, similar formula, 1/4 integral -1 to 2. 2 minus x squared plus x, as we're used to doing, squared dx. Just be careful because that's not always squared, so just keep that in mind. You get about 2.03. It's very exciting stuff. And the last shape that we're going to look at, which they will always give you this shape just so you know, so you don't have to actually like calculate this every time, just use the area that I'm giving you. So you don't have to like derive these, but if they describe it the way it is right here, that will hopefully help you out. Okay, semi-ellipse. Hopefully some of you remember what an ellipse looks like. The ellipse, a full ellipse, that was terrible, should look like an egg, whose height are 3 times the length of their base. So I want to just remind you of a few things. Okay, an ellipse has an A and a B value that are distant, you know, they're not equidistant, but they're a distance from the center. Okay, the formula for the area of an ellipse is going to be pi a b. Okay, the other thing you should notice is if it's a semi-ellipse, that means half of an ellipse. Okay, so in this case we can look at a figure that's a semi-ellipse. So if I drew it out, you could make it something like, it would look like that basically. This whole bottom part would be your B, okay, across. If you can see in the original diagram, the whole thing is usually going to be your B. So that means we are going to do, we're going to do half of that. If it helps you, this is basically B. If you want to call this like B2 because it's our base in our formula, this would be half of that, which is the B in this part. Okay, so you end up getting your B over 2 for your base here. Okay, so this part is b over 2. And then it says the height, which is like a, right, is 3 times the length of the base. So it's going to be 3 times b, okay? So it should be a lot longer than the actual base. So the easiest thing to look at for this is plug in those values that you have for the a and b values. So a is really 3b. B in this case is really b over 2. So if you plug in, you get pi times, again, the a value is 3b. Your b value is b over 2, because your b value in this case is like half. And this is half of the whole base. And then it's divided by 2. So that simplifies to, kind of move this up a little bit. Let's make it 3 pi over 4, because the 2's multiply. You got a 3 and a pi there, b squared. Okay, so that would be your area, given that your shape of your cross-section, is a semi-ellipse. So again, you would integrate, pull out the constant, sorry, that's a pi, 3 pi over 4, from -1 to 2, 2 minus x squared plus x, all squared dx, and you get about 19.08. So again, they'll give you whatever shape your cross-section is going to be. And then you just have to use the formula given. So now you don't have to derive them, you just have to know them. Alright, so this is the actual real example of this, where you can see it says find the volume of the solid whose base is bounded by the functions x squared, y equals 4, and x equals 0 with the indicated cross sections. So if your cross section happens to be a square, the formula that we used was just b squared. But your cross section in this case is the actual function. You're going this way. Okay, it also says it's perpendicular to the y-axis, so that's why I'm cutting across, which also means that we need to be in terms of y, okay? So in that case, you're gonna set your equation to just be in terms of y. So you get x equals radical y. I'm just making an x equals, okay? So now you're gonna be integrating between your y values. In this case, it's between 0 and, this is y equals 4, so 4. So 0 to 4. If you're talking about a square, it's your base squared, and our base in this case is whatever my cross section is. So it's literally the radical y squared, excuse me, dy, which you can plug straight into your calculator. Okay, and you end up with 8. Okay, I'm going to have you take a sec and try the semicircle one. Very similar, you just look back at the formula for a semicircle, and plug in your function, and then simplify. And you can use your calculator to find the integral. Alright, hopefully you had the formula down. So it was 1/8 pi times your base squared. And again, your base is a semicircle, and it's the function given to you. So you plug in the function. So if you wanted to integrate by hand, you can, or you can use your calculator at this point, and you end up with pi. If you want to be real exact, use your brain instead of your calculator. But you probably will recognize that the 3.14 was pi. All right, folks, that's all she wrote, aka me. That's all I wrote. Have a great weekend if I don't see you. Some of you I won't see, so have a great day, and we will be reviewing next time I see you.